Hello guys, welcome to my channel Electrotech Center. Today we are going to learn how to interface LED with PIC18 microcontroller. So first of all we will go through schematic design. So let's open Proteus software. So here you can see I have taken PIC18f4520 microcontroller. I have connected one LED to RB0 pin. Also connected crystal circuitry to 13 and 14 number pin and connected reset circuit to pin number 1. So this microcontroller support active low reset, which means you have to give low signal to reset this microcontroller. So I have explained how this reset circuitry works in my previous video, so you can watch this video. So before going for coding, I will explain some basics of this microcontroller. So this is 40 pin IC which have 5 ports, port A, B, C, D, E they have given. So as you can see here, each pin is a multifunctional pin. So for using any functionality, you have to configure some register for that. So in coding I will explain each register. So for coding we are using MPLAB IDE. So let's open MPLAB. So first of all you have to create new project. So click on next. Here give your controller name and click on next. Select your compiler. If you don't have compiler, you have to install XC8 compiler. I have already installed that, so here it is showing XC8 and then click on next. Give your project name here. Give location to store this project and after that click on finish. So here you can see our project is created. In source file you have to add your C source file. Give name for this source file. You can see here source file is added successfully. So I have written code to blink LED. So I will explain this code line by line. So first of all you have to include header file for PIC18 microcontroller. So header file I have included is xc.h. So you have to configure some bits for oscillator. You have to use HS here. So why HS is here? So actually for below 4 megahertz you have to select here xt and above 4 megahertz you have to give here HS. That is the configuration bit for oscillator. So next configuration bit is watchdog timer. So you can make it on and off as per your requirement. I am making in this code off. So next bit is low voltage programming. You can make it on and off as per your requirement. So you can write to as I have written here. You can also do this configuration from this configuration bits window. Here it is given configuration bit window. So oscillator option is given. So many options are they have given. So void of timer and low voltage programming. Here you can make it on and off. If you are making it on and off here, you don't need to write to that line of hash pragma in code. So I am writing inside my code, that's why no need to worry about that window. So after that I have declare one delay function here. So inside main, I have configure one register which is add common. So this register you have to configure. So I will explain inside datasheet. So here this register is given. So actually this is ADC control register. So here in Proteus you can see I am using RB0 pin. So AN12 and INT0 is also working for this pin. So which functionality you have to use? As per this functionality you have to set that register which is addcon1. So here bits are given. This is 8-bit register. So last 4 bits are used for ADC port configuration, and this 4th and 5th bit is given for reference voltage selection. So you can see here for analog A is given, for digital input output D is given. So I have to use as a digital pin. So that's why you can see here you have to select to this bit 1 from 0 to 3. You can reset these bits if you want to select these pins as analog pins. So that's why you can see here I have made this last 4 pins, last 4 bits 1. So I have to use as a digital pins. So it is a register which we call tri-state register. So TRISB is used for making your pin input or output. So if you clear this register, it will work as a output pin. If you want to make it input, then you have to set these bits. So that is use of TRISB register. So next register is port B. So port B is used to set or clear your output pins. You can also read this port B register if you are using that pin as an input pin. But currently in this program I am using RB0 as output pin. That's why I am setting RB0 by using port B pin port. So I have set this bit, provided some delay. Again I am making these pins 0, provided some delay, and this will run infinite amount of time. And lastly, after main program, here I have defined delay function which I have explained in my previous video. So this is all about coding. So let's generate hex file. So generating hex file, you have to click on this production tab. Inside production, build main project is given, so click on it. So here it is showing some error. We have to remove this error. So in error you can see extraneous closing braces are given. That means you have given some extra braces here. So remove it and again make this build. So now you can see here build successful message they have given, and loading completed is also completed. So now we can load this hex file inside your microcontroller. So double click on this microcontroller, select your crystal frequency, select your hex file. So inside this folder, go inside default production. So you can see here .hex file is generated. Select it, click on OK. To see output, start simulation. So you can see here LED is blinking as I have written in code. So that's meaning code is correct and our all connection is also correct. So in real hardware you have to also connect power to 40 number pin and ground to 20 number pin, and for loading hex file you have to use external programmer. So this is how you can write code for this 80 PIC controller. So in next tutorial we will see how to interface key to this PIC18f controller. So thanks for watching this video.